So today we're going to be naming ketones the IUPAC way. So the first step you want to take is you want to name and number the parent chain, okay? And so to do that, the parent chain is always going to be the longest chain of connecting carbons. And so we could do 1, 2, 3, 4, 5. We see that that's a long chain of carbons. There's 1, 2, 3, 4, right? But we want to stick with the longest. So you could see that this is the parent chain, right? But you can number it 1, 2, 3, 4, 5, or you can number it going the other way, 1, 2, 3, 4, 5. The way you want to number it is by putting the substituents, which is this carbonyl group and this methyl group. You want to put them at the lowest numbers. And so we would number it like this: 1, 2, 3, 4, 5, because this way gives this carbonyl group a 2 and this one a 3. If we go the other way, we're looking at a 3 and a 4 numbering, and that's not the way we want it. So 5 carbons, right, that corresponds to pentane. But for aldehydes, we're going to change pentane into pentanone. So basically this E becomes an O-N-E. And this is the same for like hexane would be hexanone, butane, butanone, any of that. It's all the same. So we know that this is going to end in pentanone. So our naming is going to end in pentanone. But we need to take into account, right, this substituent and, of course, the carbonyl group. And so we see that the carbonyl group is at 2 and the methyl group is at 3. What you want to know is that to identify the placement of the carbonyl, we're always going to put that numbering at the end right before the pentanone. And this is what I mean by that. So if we're numbering this, if we're naming this, we're going to say 3, and we always separate a number in a word by a dash. So we're going to put 3-methyl, and then now we can talk about where the carbonyl group is, dash 2 dash pentanone. We cannot put 2 dash pentanone dash 3 dash methyl because we always want to end in this. And so this number, identifying where that carbonyl group is always going to come right at the end before the pentanone. So that's how you would name this for a chain. Okay, so now we're going to be naming ketones that are in a ring form. So we can see that we have a cyclohexane as the base. And so what we're going to do is we're going to do cyclohexane, and cyclohexane, same thing, E becomes O-N-E. So we have cyclohexanone for ketones, okay? So we know that that's a ketone, but a cyclohexanone by itself is just going to look like this ring without these substituents. So we need to number and name the substituents. So in a ring, you always make the carbon connected, the carbon of the carbonyl, your number 1. And then how do we know whether we're going to go 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6? Once again, we want the substituents, right? We want the substituents to have the lowest numbering. So we're going to go 1, 2, 3, 4, 5, 6. And so now we know we have an isopropyl group at the 3, and we have a methyl group at the 4. And so we can name this like such. We can do 3 isopropyl, 4 methyl, and you don't have to say dash 1 dash cyclohexanone because we know that the carbonyl group is at the 1 because that's how you have to name ketones when they're in a ring. So from here you can just say cyclohexanone. Alright, and so that would be the proper naming for a ketone in ring form. Okay, so we're going to do one last example. As you can see, this is a large chain. There's a lot of substituents going on, but the first step is always just to find the parent chain, and that's going to be the largest number of carbons that you can connect. And so if I'm looking at this, it looks like it starts here, and you can go all the way down here, and that would, I believe, be 1, 2, 3, 4, 5, 6, 7, 8 carbons, and I don't think any other route you could take would give you more than 8 carbons. So this is going to be our parent chain. We want to start from here and number this way and end 8 here rather than start 1 here and end 8 over here, because it puts our substituents at lower numbers. What I mean by that is if we number 1, 2, 3, 4, 5, 6, 7, 8, it puts our substituents at 3, 4, and 5. Where if we number 1 over here and end 8 over here, it'd put our substituents at 4, 5, and 6. So we want to number it like this. Remember, we have 8. 8 corresponds to octane. Remember, E becomes ONE, so for ketones. So we have octanone. It's going to end this. But we need to identify where our substituents are. So we know we have our carbonyl at 3. Remember, you always want to put the 3, identifying the location of the carbonyl right before the octanone, so that's going to go at the end. But we also have a methyl group here and an ethyl group here. So what we want to do is you want to say, okay, you could say 4 methyl, 5 ethyl, but in this case, we're going to put ethyl before methyl, and this is simply because we look at this alphabetically now. So you would name this 5 ethyl dash. Remember, dashes are going to separate numbers and words always. So 5 dash ethyl dash. Now we've got to number the methyl. 4 dash methyl dash 3 to signify where the carbonyl is, and then now we end with octanone. So it's pretty simple. The only little tricky one here is that you do have to look for the alphabetical, the lettering of the beginning of your substituent. So since E does come before M, you would number this 5 ethyl 4 methyl rather than 4 methyl 5 ethyl. But other than that, that's how you would do this example. If you have any questions about this, I know it can be kind of confusing, just leave them in the comments below. If you have any examples you want to show me, I can attempt them. But other than that, I hope that was helpful, and please subscribe.